Good evening to all. Today we are discussed about ultrasonic inspection techniques. There are two type of techniques. One is the reflection mode, another one is transmission mode. Reflection mode or through transmission mode. The two type of technique to examine the samples which have any defect inside the materials. First one is reflection mode. This is the most common technique. Already we have discussed the similar technique in pulse echo system, which is also look like that here, pulse echo system. But in pulse echo system we are using two type of transmitted probe. That is, one is transmission probe, another one is receiver probe. Here in reflection mode, the transmission and receiving probe is a single device, is including a single device. Here the sound pulse is fully or partially reflected from the defect of the samples. Fully or partially reflected from the defect of the samples. Reflected signal is also collected by the receiving probe. The transmitted probe, they transmit the ultrasonic pulse into the samples. First one is to fall on the surface of the sample, which collect the transmitted probe, which will exhibit the signal, that is left side of the CRO, that is full strength signal or reflected signal. Second one, if the material gets any defect inside the materials, means the pulse, that is ultrasonic pulse, to fall on the substance or defect, the reflected back echo pulse is also received by the receiving probe, which exhibit the echo from defect pulse. Already we discussed the pulse echo technique, similar like that. The echo pulse is in between the reflected pulse, that is a back echo pulse, and initial pulse. This is the initial pulse. If there is no defect inside the materials, means you will get the another one back echo pulse. From this pulse you can determine the depth of the defect by the formula is D is equal to Vt divided by 2. Here V is the velocity of sound, T is the time interval, and divided by 2. In these methods, so what are the merits in these methods? Here only one side inspection is sufficient for these studies. So you can examine the sample any area, you will take only one side, examine in the samples. But in the same case, through transmission methods, you can examine both sides of the samples. That's why this is the merits of this method. Second one, the specimen of any shape can be studied. Why? Because we are using only one probe. This probe, it acts as a transmitted and a receiver probe. So you can easily move all the surface area. So if the materials have difficult structure is also, you can find the defect inside the materials. Any shape you can examine. And next one is the coupling loss is less. Why? Because we are using only single probe, which means it acts as a transmitter and receiver probe. So the sound pulse is easily absorbed by the CRO. The next one is the depth of the defect. The depth of the defect from the surface can be measured. If we can measure the surface of the defect is also measured by using this reflection mode method. Second one, through transmission method. Through transmission method. In this method, the transmitted probe is placed one end of the specimen. The receiver probe is placed other end of the specimen. That is transmitted probe. the bottom of the samples receiver probe. The first one is transmitted probe, which is top of the samples, and directly opposite to the receiver probe, which is fixed bottom of the samples. In this method, you can move both transmitted probe and receiver probe together simultaneously. At the same time, we can move the transmitted probe and receiver probe. Here, the receiver probe gets full signal when there is no defect inside the materials. That is, which exhibit the initial pulse. If the materials have no defect, means you will get the initial pulse, that is high intense initial pulse. Then if the materials gets defect inside the materials, means the signal is decreasing, that is defect echo pulse. Due to this partial reflection, the ultrasonic waves received by the receiver, which exhibit a small intense peak. Now, the presence of defect is known by additional peak due to the reflection from the defects. Already you know that. Here also we are discussed. In addition that, you will get one peak, means the material gets any defect inside. What are the demerits of this transmission through transmission method is, here we are using both side of the transducers, that is probe. It is very difficult. This is one of the disadvantages of this method. Another one is surface of the sample must be parallel, and the coupling loss is more. In this case, there is very less when compared to the through transmission method. Here the coupling loss is more. Why? Because we are using two different transducers. That is the transmitted probe, another one is receiver probe, and the depth of the defect cannot be determined. In this method, we are not able to find the depth of the defect. This is the one of the failure case of this through transmission method.